Okay guys, it's me Imad. So today in this video tutorial we will learn about how to use the function generator or wave generator within the simulide simulator. So how we can do that? First of all, we need to go to our component search box and here we will write wave generator. Or just write wave and it will give us our wave generator. So click on it and drag it to the main circuit window. So now this is our simple wave generator. It can produce certain waveforms like sine wave, sawtooth wave, or some random type of waveforms. So how we can observe all these waveforms? We go and we can write oscilloscope in the search box and it will give us our O-scope or oscilloscope. Drag it out and this is our oscilloscope. Now we need to connect this oscilloscope first channel, that is yellow one, with the function generator. And now our scope is connected with the generator, so we can run it out. We can click on our generator and now we can see that our waveform has been shown on the oscilloscope. Double click on this function generator and it will tell us about all the options. That what sort of waveform we need, and we can change its type, that is from sine to sawtooth and from sawtooth to triangle. We can also show some random waveforms on this oscilloscope. We can change its frequency here, 1 Hz. Okay, we can write it like this. Now you can see that we can change our frequency here. Frequency simply means that certain number of cycles in the same time. If we consider just 1 second on the horizontal axis, it will give us the cycles or frequency. That is, more is the frequency, more are the cycles. Now you can see that we are getting more and more cycles here of random. And square wave, for square wave we also can get more and more cycles while changing frequency. Now with the help of this function generator we can produce certain waveforms of different voltages as well. Like double click on it, go to electric one, and we can change from like it is 2.5 on the positive side and 2.5 volts on the negative side, that is from peak to peak. Okay, so we can change its voltage. Now you can see that it is getting more and more big. Okay, and this is 0.5, that is 0.5 volts. We can expand it out as well like this. You can see, okay, we can also change its time position. Okay, now this is our time. Not time position, time division. Okay, we can go for our channel 1 time divisions rather than time position. Okay, now you can see we can change the time, and time change simply means that in one box it is of 4 millisecond. In 4 milliseconds we just got we just got around one cycle, not more than one cycle. Okay. Now can we go for certain more? Okay, it goes to picosecond. Now we can increase it out with the help of arrow up button, because picosecond is very less. Now we will go in the nanosecond. Okay, now in microseconds we are getting certain cycles. Okay, now in milliseconds then we got proper waveform. Because if the time division is very less, we are not going to observe this cycle because frequency is less. If there are more and more cycles, then we can observe. Okay, and if there are very less cycles, then we have to what's called as increase our time division, or sorry, decrease our. Okay, so just like this, in picoseconds, and again then that's it. With the help of page up function, we can even go fast. Okay, like this. So in 11 millisecond we can, if 11 millisecond is just representing one box, it means that we got around 2 to 3 cycles. Okay, but if we can decrease it down to 1 millisecond, then we can hardly get 0.5 or 0.4 of the total cycle. Okay, so 11 millisecond and 1 millisecond. Okay, so because frequency is less, and if we can change its frequency from kilohertz, so now you can see that in order to properly observe it out, we have to decrease its time division. Because picosecond is still less, we will go for nanoseconds and microseconds. Then we got certain cycles. And in time position, we can change this thing as well. Okay, because this is also certain problematic, so we can change it out. We can change its time position first and make it like this. Okay, wait, so this is the thing, and now we can observe it properly. Now you can see that we got our waveform here, and time division is 22.64 microsecond, and we got our certain 4 to 5 cycles in it. So hopefully you got the concept that how you can use the function generator within the simulide simulator. So thanks for visiting our channel, and don't forget to subscribe.